Okay, I guess we can get started. So today in the Vaadin Meetup group, we have Arun Gupta from RedHat joining us. And Arun has been in the original J2EE group writing the spec back in the days. Maybe you can introduce yourself quickly.
Yeah, well, my name is Arun Gupta. I joined Sun back in 98, 99. 98 is when I got interviewed. Classic case, sun.com/jobs. That's where I applied. My hiring manager said, "You want to work for the JDK team?" It's like, wow, that sounds pretty cool. Whatever it is, I'm in. And that's how we started the J2E team. 14 years at Oracle and now at Red Hat. I'm the director for developer advocacy. So looking for people, talking to developers, talking to engineers, helping them understand the technology. I focus on the JBoss middleware, and JavaEE 7 is one of the components of it. So to me, really, the presentation should be a lot about code. The code should do the talking, then the slides do the talking. So this is a code-driven orientation or a code-driven presentation around JavaEE 7. But basically what it is a bunch of code samples that have been written by the community. So it's a GitHub project. GitHub JavaEE samples is the organization. And in JavaEE samples, there's a JavaEE 7-samples repo. So that repo is a collection of about 200 samples/tests. That's how, I started writing these samples about 2 years ago that I wanted to understand the technology. New specs are coming along. How do I get to understand the technology? So you write the technology. You write the simple tests. And then over a period of time, as you can see, there are 36 contributors to this project itself. People who are coming from all around the world, contributing tests, samples, filing issues that, okay, I want to see this sample and things like that. So this is the workspace that I'm going to use today to help you understand some of the key concepts of JavaEE 7. Okay, so that's the first thing squared away. You have access to all the source code that I'm showing today. This is NetBeans IDE. NetBeans IDE is the best IDE for doing your JavaEE 7 development, although it's supported pretty well in Eclipse or JBoss Developer Studio and IntelliJ as well. Okay, so what I've done is I've opened up this Maven project. It's basically as a Maven project, and each Maven project is a bunch of modules. Now, in JavaEE 7, there are 4 new technologies, brand new technologies those are added. So I'm going to focus on those first. So those are Websocket, that's JSR 356, or second is batch. So we have support for batch processing in JavaEE 7. Then there is JSON support, so JSON processing support, so low-level API, so there is support for JSON. And last but not the least is support for concurrency utilities, how you can spin up your own user threads very easily in a managed environment. So those are 4 new technologies that are added to the platform. So I'll show you samples for all of those. And then depending upon time and interest, we will be able to see JAX-RS. There are a lot of cool additions over there, which is a RESTful way of writing web services. Or JMS, where the APIs are extremely simplified, so we can take a look at those as well. And there are a bunch of areas, JSF, JPA, EJBs, where are some minor improvements have been made, so we can take a look at that. First thing first, so let's get started with WebSocket. Now, if you want to understand how the WebSocket works, and the way this is how I started. If you look at WebSocket, there are about 30 plus samples, which shows you exactly how a WebSocket application can be written. There are different concepts of WebSocket. So what's the relevance of WebSocket, first of all? Now, HTTP has worked very well for us so far. It's a two-way traffic, request-response design pattern, chatty protocol. So for literally 11 bytes of hello world, I wrote a simple app. You were exchanging 643 characters back and forth from client and server because only 2 HTTP headers are required. But the moment you start using RESTman client or Postman client from the browser or any client for that sake, and the moment you start using any server, which is what you do, they start sending and exchanging a lot of headers back and forth. So 650 characters for about 11 bytes. It's a lot of overhead. And that's where WebSocket kick in. WebSocket says, hey, by the way, we're going to take an existing HTTP connection. We can upgrade it to WebSocket. It's a standard HTTP terminology. We can upgrade to WebSocket. And once upgraded, it's a very lean protocol in the sense, there are literally 2 bytes of overhead for any message that you send, and the message size pretty much can be huge, and it divides messages into frames and all those things. We won't get into that, but the point being, once you have the WebSocket connection set up, then you can exchange a lot of messages back and forth between the client and the server in a very lean manner. Okay. Now, WebSocket allows you to exchange text and binary data. So the key benefits of WebSocket in that sense is, first of all, unlike HTTP, which is for every request, it's a new response, even though you may do keep alive, all that stuff, but the applications can't rely upon that. So for every client request, there's a new HTTP request and a new TCP being initiated. For WebSocket, once you have initiated the connection, it stays open with the server. That's one. Second, HTTP is always client initiated. So where you say, oh, you know what, I'm the client. So I'm the client. I'm going to initiate a request. So we're going to process it. So we're going to send me a response back. So server has no way to push it back, unless you use long polling and all those things. And there are 500 ways of doing long polling. So that's that. And then it's very chatty protocol, as I said, 650 characters for every 11 bytes. And that 650 characters kind of stay constant. The message size can go higher, but still it's a pretty chatty protocol. And if you have to do thousands of those message exchanges, that 650 characters turns out to be junk. So in terms of WebSocket, the advantage is you take an existing HTTP connection, you upgrade it to WebSocket. So that's one. Second, it's a full duplex connection. So client can talk to server and server can talk to client. And they can talk to each other at any point of time. So it's full duplex bi-directional communication channel over a single TCP connection. So that TCP connection stays open until one of the parties explicitly say, we're going to close it down. Okay? So let's take a look at it, what that means. So let's see how I'm going to write my canonical chat sample using WebSocket. Now, JavaEE 7 introduced JSR 356, which is a standard way of writing WebSocket-driven applications. Could be a server endpoint, could be a client endpoint, any of those. So what I'm showing you here is, let me increase my font size first. Is that readable? Far at the back, can you read it?
Oh yeah, it looks perfect.
All right. So here, this is my Pojo. If I want to convert this Pojo into a server endpoint, I just add the annotation called a server endpoint. And when I say server endpoint, I need to specify the URI at which it's listening. So this Pojo bundled in a WAR file by itself makes this Pojo as a WebSocket endpoint. No deployment descriptor required, nothing at all. Now, of course, this is bundled in a WAR file, so whatever the context root is, /chat becomes the endpoint where WebSocket is listening. WebSocket endpoints listen at ws://URL, unlike HTTP. They do get upgraded from HTTP, but the URL is ws://. That's a new URI scheme effectively introduced by RFC 6455, which is how the WebSocket protocol is defined. So you say, this is where my WebSocket endpoint is listening. Now, a WebSocket endpoint can receive a text data or a binary data. So once the data is received, you go to dispatch that to a business method. How that business message is identified is by putting the @on message annotation. Oh, call this business method when you receive the data. And what kind of data? Well, it could be a text payload, in which case it's a string parameter, or if it's a binary data, it could be a byte array or a byte buffer, either of those. Okay. Optionally, you may specify session, which basically describes the conversation between the client and the server. Now, one thing to understand is with WebSocket, the typical connection is a hub and a spoke model. So it's not true peer-to-peer. It's not like client is talking to client. What happens is client talks to server, and then if it needs to talk to another client, the server basically broadcasts the message. Now, you could build a protocol on top of WebSocket where it's multicasting to a particular protocol or is point casting to a particular client. So you build your own protocol. So WebSocket is a very low level protocol on top of which you have to build everything. Okay, that's the important part to understand. So once again, it's a hub, is the server endpoint. All these different clients are sitting at the edge of the wheel, who are then talking to server, and then server broadcasting to other clients. It's a very classic way of doing chat messaging anyway, or IRC rather. So here, you get this string payload, and all you want to do is broadcast it to other clients listening to the server endpoint. So you say, okay, client, which is basically the endpoint coming in, give me all the open sessions, and then you iterate over them. You say, give me a handle, remote handle to those clients, and I'm gonna broadcast a message. As simple as that. So just that, literally, say 12 to 21, in about 9 lines or 10 lines, we have our canonical chat server ready. And that's it. That's all it takes to build a simple WebSocket endpoint. Now, you may not want to receive text and binary data in the raw form every time. So here, for example, you're receiving string message. It's a simple message chat, so you can broadcast it back. But what if you're receiving a complex JSON or a complex XML or things like that? So then you may want to take that raw data, convert that into a business domain POJO. And then you may not want to mix and match the code here, wherein you're taking the string and converting it into POJO here. What you may want to do is you use this design pattern, where you have encoders and decoders defined in as part of the API itself. So for that, let me show you another sample here. So here, I have another sample, which is a collaborative whiteboard. Now, in this collaborative whiteboard, all I'm saying is, it's let me run the sample first. So I'm firing Wildfly, which is the application server that I'm using today. In case you're wondering, what's that name? My laptop broke. My display of my laptop broke on my flight to India. So I just borrowed my mom's laptop. She happened to have a MacBook Air lying around. Funny, isn't it? So I'm going to build this package here. Oh dear, yes, sir. My mom has never used Maven. Funny. It's going to take some time to build the app anyway. So I got my war file here, and I don't think we have the Wildfly plugin, but let's try that. Yeah, never mind. I'll just drop it there. Okay, there we go. Okay, so this is my collaborative whiteboard. That's one. And I'm going to open up another window here. Which looks like this, okay? So let's see, I haven't tried this sample on this machine ever, so I don't know if it's going to work. And it worked, cool. So I click anywhere on this HTML5 canvas. Whatever I do here, it gets reflected in the other browser. I could change the color, and then it gets reflected. Then I can change the shape and the color. Whatever I do gets reflected. And then I can go here, choose green, and it gets reflected otherwise also. Okay. Now I can say, oh, by the way, I'm going in offline mode. So my app is no longer shareable. So I can start creating some other values here. Okay. Now I can say send a snapshot, and it sends a snapshot. So that's sort of the basic application. Think about it's a multiplayer game and collaboration happening that way. New player joins in, you can send a snapshot, all that goodness. So what's happening here is every time I'm clicking on the browser here, so if I can bring up developer tools here, for example. So let's refresh this page. Let's refresh this page. Go to network here. Okay. I can start filtering on WebSockets here. So it's showing me only WebSocket messages. I click here and I can look at the frames now, because WebSocket, the way communication happens is using frames. Okay. So now I can click here. Okay. The canvas is getting refreshed. So that's happening good. Okay. Now let's go offline here, move some data, and send a snapshot. Okay. Now you see in Chrome developer tools, this is not getting refreshed because that's a bug in Chrome itself. But if I go back here now the data is being refreshed. So what's happening is, first time, if you see, this is the first data that has been received. So every time I click around in the whiteboard, is capturing the JSON coordinates, say X, Y, color, shape, and is transferring that over the wire, which is in terms of WebSocket is a text message. So the WebSocket receives a text message, the client sends to the server broadcasts to all the other clients, and the client receives that JSON coordinate and refreshes itself. So that's a simple one. And in terms of sending a snapshot, I'm grabbing a binary array of the HTML5 canvas, and then I'm doing the same thing. I'm sending it to the server broadcasting it to all the clients, and then they refresh themselves. Okay. So that's what is happening at the application layer and at the WebSocket layer. If I look at the source code behind it, so this way it's listening, WebSocket. It's got an encoder and a decoder, which is my design pattern where I'm going to say the JSON message is being received, convert that JSON into my business domain object and vice versa, because on the wire it has to be string. Okay. There are some lifecycle methods here, on, open, on, close, so we won't go into details though. So now when I say broadcast figure, instead of saying string, I can say figure. And why I can say figure? Because if I look at my figure encoder here, it's saying, oh, you know what? I know how to take a figure and convert it into string. That's one. And in figure decoder, I can do the opposite. I can take a string, convert it into figure. And that's where I put my business logic of converting that string to JSON to POJO and vice versa. So you define your encoders and decoders and keep your code confined to that, and your business or the WebSocket endpoint kind of looks kind of clean. Okay. So in terms of WebSocket, there is a lot of samples here. So for example, what I showed you how declarative WebSocket endpoint would look like, or annotated endpoint would look like. You can also do programmatic, which gives you a lot more control over how the WebSocket connection handshake happens, what headers flow back and forth, and things like that. You can also do asynchronous WebSocket endpoint. So there are samples for that. One of the typical use case people ask is, how do you compare WebSocket and REST? So I got a simple benchmark for that over there. I'm not going to run it, but it at least allows you to compare WebSocket and REST. It's a simple echo endpoints. You send message and you get the data back. But typically what I've seen is for smaller number of requests, and smaller I mean 10, 20, 30, maybe up to 50, at the max 100, the difference is not that visible. But the moment you go in a higher scale, higher as in like 500 or 1,000, much higher, lot more the difference is. In the sense, it could be up to even 100 times better WebSocket connection. And in terms of the response time, because guess what? Every REST request is creating a new TCP, new HTTP, and tearing it down. And it's sending all those chatty headers. So that's where the concurrency of WebSocket comes in handy. Because WebSocket, on the other hand, as Matthew would recognize, we have been playing with WebSocket scalability this morning. WebSocket scalability is a lot about how many file descriptors are available. So on Linux, hypothetically, you can go up to 4 million file descriptors, depending upon the state of the machine. So you can literally have that many concurrent connections. Wildfly, for example, we have been able to test up to on a random developer machine, where the guy who's doing the WebSocket development for Wildfly, we have been able to test up to 80,000 concurrent connections very easily for WebSocket running on Wildfly. So that's normal for WebSocket connection. By the way, feel free to ask questions. If you don't ask questions, then I'm going to ask questions.
Is there a client part of this endpoint if you want to do machine-to-machine connection, communication using WebSockets?
Yeah, there is. So WebSocket, as I said, is not a true peer-to-peer anyway. The way you have a server endpoint, the same way you can have a client endpoint. So client endpoint also listens, but it only listens from the server endpoint. Client endpoint cannot listen from another client. So if you want to do a machine-to-machine communication, it has to be through the server. So then as part of the payload, you define, oh, you know what, I'm sending this to server, it's out-of-band negotiation. The server has to understand, oh, this is the payload coming to me, and as part of the payload, this is a JSON payload, and it is targeted at that client, and then the client has to give it some UUID, and then based upon that, you establish the connection with them. Yeah. So it's completely low level. It's literally opening a socket on the web for you, and you define what you want to do with it. How many of you are using WebSockets today?
Everybody.
How to use them.
Okay. In production? Okay. All right. Because there are a lot of good issues that happens in WebSocket putting in production, ghost WebSockets, DNS, firewalls, JavaScript optimization, closing connection, timing out. There are lots of fun things that happen with WebSockets, so just to be aware of all these aspects. All right. Second technology I'm going to talk about is batch processing. Now, how many people use Spring Batch? Nobody. Okay, one hand. Spring Batch. Spring Batch. Okay. So Spring Batch is where this batch functionality has been borrowed from. It basically gives you an ability to do bulk processing or item-oriented processing. What that means is, think about you're running a movieplex. In the movieplex, you receive CSV files from different cinema halls, and you want to do the processing to calculate the sales, for example, or persist that value into the database. So maybe you have 20 files. Each file has, say, 1,000 of records, depending upon, each ticket sale is a line, it's a line. So what you want to do is you're going to read that file line by line. You're going to validate it, and you're going to store it into the database. And you're going to read 20 of those files. That's a classic batch processing example. Or at end of month, you want to generate, for example, emails, monthly bank statements, or employee statements, right? Whatever you want to do. So that's the use case that's being served by batch. So if I can show you a very classic example. So here, what you see is, I have a reader. Well, first of all, this is how you define a batch job in JavaEE 7. This is a job in the JavaEE 7 namespace. A job can have multiple steps. What I'm showing you is a canonical job, so just a single step here. Now, a step could be of the type chunk, which is what we're saying is we're gonna do a chunk processing. We're gonna read a chunk of items, we're gonna write a chunk of items. So you define what the size of the chunk is. In this case, is 3. And then within a chunk, what you have is a reader, processor, and a writer. Reader is what's going to read from a stream. Could be input stream, file stream, REST endpoint, JMS, doesn't matter. Processor is going to take that item that is being read, validate it, either throw an exception or return null or whatever, in which case that item is ignored. And then the writer is the one that's going to write to a stream, database, file, REST, whatever it is. Okay. So let's take a look at what my reader looks like. So here I have an item reader which extends abstract item reader. Okay, I go to mark it as @name because of CDI. This bean is then injectable into the job specification language or batch job.xml. So I'm just overriding a simple open method. My data.csv in this case is already packed into my war file. So I got some data in there. I packed the data file in there. So I'm just reading it using class loader. As I said, this could be from a database, from a file, REST endpoint, whatever it is. But you initialize a stream here, and read item is where you are returning one item at a time. That okay? I'm going to return reader.readLine, and if it's an IO exception, or then I just catch it. If I don't return anything, then I can return null, which is basically saying, okay, I have no more items to read. So this is your reader. Whatever item is being read here or returned here is available in the processor, which is basically saying implements item processor, same thing at named, and the item is being made available here. Now here, this is my business logic where I am validating that what is it that needs to be validated. Okay, I want to make sure that the date is strict leniency check. That's what I'm doing, yeah. Set leniency false, so it's a strict leniency. And if there is an error in formatting the date, then return null. That means this record is not to be written anywhere. And then if the record is valid, then I can return a new JPA entity. So think about reading a string and returning a JPA entity. So those two could be completely independent records. Finally, you have an item writer. Now, item writer is taking list as a parameter. And the advantage of that is for every read, you may not have a write. Or for every read, you may not want to write. So then what you do is you read, you process, you aggregate in the writer. And that aggregation actually happens in the list. So you read, process, aggregate, read, process, aggregate, chunk item number of times. So in this case, for example, I'm saying 3. So my file has say 10 records. So it's going to read the first 3 records. Well, read 1 record, validate it, aggregate it. Read second, validate, aggregate. Read third, validate, aggregate. And the moment you reach the third record, it says, oh, you know what? My chunk item counts is reached. I'm going to write it to the database or whatever that logic is. It's basically going to invoke the writer for you. So here, in this case, all I'm doing is very simple JPA call, iterating over the list and persisting the entity. That's it, straightforward.
So does it always end, a chunk always ends with a writer?
Right. One of the cool things here is, if I say 10 records, right? So 3, 3, 3, and 1. 1 is the last record. So it's basically going to execute 4 total steps, right? Each step is container managed transaction. That means the reader, processor, and writer, they are an atomic operation for that chunk item. Either the whole succeed or the whole thing fail. And then there is automatic checkpointing that, oh, you know what? There were 100,000 records I was reading. After 50,000, the job has failed. So that doesn't mean it's going to start from ground zero. It's going to start from 50,001th record. So there is automatic checkpointing. It starts from there. But for now, it requires manual restarting of the job. It's not automatic. So effectively what you need is a dashboard which shows you the current status of the batch jobs. And then say, oh, these jobs are stopped, and I'm going to click restart the job. APIs are available, but the tools are not available. So when we do EAP 7, which is the commercial version of Wildfly, one of the tools like that you will be able to use.
So they are persistent somewhere, these batch states.
Yes.
For example, if the Wildfly server would crash, would it then remember where it was?
It does. It does. It does. So for now, Wildfly uses in-memory database, H2. That's where all the tables are stored. So if Wildfly crashes, the state is lost as well. But effectively, it's any JDBC resource because it is this is my JDBC resource where I'm going to persist the database tables for batch. So you could find this to a persistent data store as well. Yeah.
And one other question about that, where you define your batch, the steps. So apparently the writer is sort of the last step inside of a chunk. I mean, you can't really do anything after that. right?
No. So
Or can you have multiple writers in one step?
yeah. No. In a step could be of the type chunk, which is what we talked about, reader, processor, and writer. But a job can have multiple steps.
Yeah.
And then you could even define a workflow, which is what I was about to show here. So for example, see the entry point to all of this is really your job XML. So if I go here and I look at job XML, and I got two steps here. So chunk is one type, the other type is batchlet, which is basically an ad hoc job. But what you could do effectively is in your war file, you may have multiple readers, processor, and writers, and you can configure them in multiple steps here. And what's also possible is, if I show you here, so you're saying, I want these two steps to run in a flow. That means they are my one logical unit. After these two steps have completed, so you're saying next is step 3. So the next is step 3. So you can start defining flows that run this flow. After that, you run this step and this step. So this sort of a workflow model. Half-baked, but at least it's there.
Is it possible to define these jobs programmatically?
Not yet. Not in the first version. Not in the first version. There are a lot of incompleteness, so to say, in the first version. The first version was like, oh, let's rush it, let's get it done. One of the big things that I see missing is, for example, support for generics. It's like, hey, you know what? I want these readers, processors, and writers to be generified.
So if you have steps, do they both steps receive the same input data, or does this first step affect what's being fed into the second step?
No, they have their own individual input. So the reader, and that coordination is up to you. So for example, here, let's say, well, in this case, this is batchlet and this is chunk. But if these two were both chunk, they both have their both own readers. That means they are receiving their own input. Now, coming back to what you said, what's possible though is, here, you're saying, oh, you know what? I got a chunk, item count is 3, item reader is there, but it's taking properties, start and end. So I know that this job is going to run on a machine with 4 cores. So I want this job to run on all 4 cores together. And to each core, when it's running, I'm going to read 100,000 records. So to each reader, I want to be able to specify property 0 to 50. 251 to 500, so on. So you can start defining those properties. So what you're saying here is you are declaratively defining the partition. You're saying 2 partitions, partition 0, start property, end property, so on and so forth. So that way you can start leveraging multi-cores of your machine. Now this could be done programmatically as well.
How about transactions in the flow example?
Right. So each step, as I said, is done in a container managed transaction. The design pattern is in your EJB. You don't want to use the EJB likely in the reader or writer because it's already running in a container managed transaction. So what you want to do is just use a CDIB or a POJO to do your write to the database because you know either it's going to succeed or the whole thing is going to fail. There is no way to make that container managed transaction for the step as a user managed transaction. So there are a lot of good things, and I think the batch expert group did a good job in kind of defining it, but there are still some refinements that needs to be made to the API to be a lot more usable. All right, so that's the batch part of it. Now, if I look at the JSON processing, Now, as I said, JSON processing is a much lower level API. Now, so unlike JAX-B, where you say, hey, here's a POJO, put JAX-B or a XML root element annotation on it, and it automatically figure out looking at properties, etc., on what it needs to map to and how it needs to map. That's not JSON processing. JSON processing is more like JAX-P, where you can say, oh, I'm receiving a JSON structure, I'm going to manually parse it, and I'm going to streaming parse it, so like a Stacks API. So that's the capability of JSON processing. But what you can still do is either consume a JSON structure or generate a JSON structure. And that again can be done using streaming API or using the full object model. So if I show you a sample here, so let me show you how will we build an object, for example, using JSON API. So I have this on line 39, I say json.create object builder. Then I create a new string writer because that's where I'm going to write it out. All I say is to JSON create writer, write the JSON object. By default, it's an empty object. Okay, so that's simple. Now I want to add elements to my JSON structure. So then I say create object builder, add apple red, banana yellow. So because JSON is a bunch of name value pairs, so this keeps adding those name value pairs. And the same logic, say JSON create writer, write it out, and that's it. And of course here we are asserting if it makes sense or not. You can start creating fancier JSON structures. So here you're saying I'm going to create an array, not just an object. I'm going to create an array. To an array, I'm going to add two objects, apple red, banana yellow, and then this is a structure that is being generated for me. So it's saying this is an array. Array has an object, apple, colon, red, parenthesis close, new parenthesis, so it's a new object, which is because of create object builder, banana yellow. And that way we can create a little bit of more nested structure as well. So that's my API to create a nested JSON or create a JSON structure in general sense. Similarly, I have an object reader too. So I'm saying, okay, I'm going to create a new JSON create reader. I'm going to read from this string. So all I should be getting back is an empty JSON object. So I just get an empty JSON object. Now I'm going to create a string reader. Same thing, apple red, banana yellow. So this has two name value pairs. And then I'm putting my asserts here, that how this value should have been created. I can do the same thing, an array with two objects. And I'm saying read array is the size equals to 2 and is the object exactly equal to the one that we expect it to be. So this is what I'm showing you is an object API. On the other hand, is a streaming API. Streaming API is more like, okay, I'm reading the JSON structure. I got a big structure that I want to read. But instead of reading the entire thing in the memory, all I want to do is tell me when you encounter a particular event. An event could be start of an array, start of a name, start of a value, or whether the value is string or integer. So you can start making those conscious decisions. I'm going to listen for those events and then I'm going to act upon those events. Act in the sense that, okay, whenever this thing happens, let me know, and then I will extract the value. So object reader writer pattern is good when you're dealing with smaller structures, but if you're dealing with bigger structures where you want to be memory conscious, then you start using streaming API. So one of the focus for JavaEE 8, for example, is to build a JSON builder API or JSON binding API, where on a POJO you'll be able to specify not XML root element, but something like JSON root element or something like that, and then be able to generate a JSON representation by just looking at a POJO and introspecting the properties. All right, so now in JavaEE or JDK, we have concurrency APIs. Concurrency APIs are executor or schedule executor or a thread factory. Those work very well when they are in the JavaEE environment, but not so in the JavaEE environment, because JavaEE is a managed environment. In a managed environment, it's not allowed to spin up your own threads for several reasons. Well, one of them being, if you spin up your own thread, how are you going to pass it the right context? Class loading, JNDI, security context, all of those. So now, JSR 236 basically leverages the JDK API and says, instead of saying an executor, we're going to give you a managed executor. Instead of a scheduled executor, we're going to give you a managed schedule executor. And the advantage is, when you spin up threads using that in a JavaEE application, those threads are running in the container context or the application context. So that way, if you try to load a class or if you try to Jndi Resolution in that particular thread, as if the container is doing it. So that's the big advantage over there. So in order to match, for example, what's happening in the JDK, there is a managed executor, there is a managed schedule executor, and a managed thread factory. And these are the samples that I'm going to show you here. So here is my simple runnable task. Now I can submit, I can create a runnable task or a callable task. Either of those would work. And then I'm going to override my run method, and I just got a simple latch countdown here. Okay. Now I can. First thing you need to do is create a managed executor. How do you create a managed executor? Well, you can inject it. So if I look at it here, I can say I want to inject my resource, but this time it's a managed executor service. Okay, and there's a default managed executor service that is provided by the JavaEE 7 platforms. So you can either use that, or you can say I'm going to define this in my web XML and then inject it, because this is by default managed executor service is 1. But let's say you want multiple managed executors, then you start defining them application specific in your web XML and retrieve it from that. So you can inject it that way. So that's one way of getting it. The other way of getting your executor is using Jndi Resolution. So you can say, I'm going to create a new initial context. From the context, I'm going to look it up, and I'm going to get the default managed executor service. Okay. And the way you define it in WebXML is, this is my executor. You define it as a resource environment reference, and you give it a resource environment reference type. Okay. And the best part is, once you have injected managed executor service, it's basically giving you all the methods that a typical executor service will give you, because it's basically inheriting from that class. So you can, submit your task, you can submit your runnable task, callable task, all of that. Or if you're doing managed schedule executor, then you can submit with delays. That, okay, submit the task every 3 seconds, and make sure that the previous task has finished. If it hasn't finished, then wait, things like that. So whatever you can do with managed schedule executor, you can do, or whatever you can do with schedule executor, you can do that with managed schedule executor as well. So, but the key part, as I said, all running in the container context.
So how these relate to this scheduled EGB methods and asynchronous methods? So how are they similar, how are they different? And when should you use which?
Right. So add schedule is used as a cron task. So you would say, well, one big difference first of all is security, class loading, and JNDI context are passed to this user created threads, not the transaction context. Because the transaction context synchronization across multiple threads is a nightmare. So it was purposely held back. We're not going to do that. In terms of EJBs, when you do add schedule, You can specify a cron-like syntax over there. You can't specify a cron-like syntax here with manage executor or manage schedule executor. So very different use case in that case. In EJB, a lot of it is container managed, right? Here, a lot of it is you are managing it. So you are spinning up your own user threads. You are explicitly starting a transaction, committing a transaction, getting hold of the security principle, enabling security unless you're running in that context already. So you only have the context. Whether you want to secure the application or not, that is up to you. So sort of big differences in that case. And EJB asynchronous, again, the same thing. It's a lot of it done by the container itself. Here, you are responsible for it. So one of the typical use cases I'll share is let me show you that actually. So this is a real-world application that was built using JavaEE 7 and deployed on Wildfly, tp.camp. This is a campground management application. Now in this application, if I show you the architecture, there are a lot of JavaEE 7 technologies that are being used. They're using concurrency as well. And the reason they use concurrency is once you get a request from the client, you need to send an email to them as a confirmation email. So they're not making that as a synchronous request. They said, you know what, because they're using a separate API called a sendmail because you need to plug in some hooks and etc. So they get the receive a request, they send them an instant reply that yes, we are sending you an email. So their web page closes the connection. In the background, these guys spin up a concurrent request or concurrent thread where they have all the context from the web application, and there they're using it to send emails. So if you really want to do your user application, user task in the container context, that's when you're going to use these concurrency utilities.
Couldn't you also just invoke an EJB with an async method in that case as well?
So even though your client is unblocked, so in case of EJBs, what you get on the client side is either a future or a void. Void is fire and forget basically. Or you get like a future object.
Yeah, but if the client is invoking your server, which is invoking an async,
right?
so would that work as well? Or would it be performance-wise better to just fire up your own thread and do it there?
It probably would be because EJBs do come with that additional transaction overhead. Unless you also specify, oh, by the way, I don't want any transaction on it. So it probably would be, but I don't know, it might be minimal actually. Might be minimal. I haven't done any benchmarking on that personally. But this is how I'm seeing people using it, because I really want to do my user thread, and I'm going to keep EJBs if I want to do something container managed stuff. So those are my 4 primary technologies that were added brand new to the platform. Okay, what I'm going to cover next is JEX, or well, let's see. Okay, anybody? Okay, so JEXRS, JMS, JPA, JSF, CDI. Those are 5 technologies. Let's see who votes for JEXRS to have a first look. Anybody interested in JEXRS?
Keep it coming.
Okay, all right.
We'll digest everything you
Well, JEXRS is a standard way of building RESTful web services. The very first version was really focused on building server-side services. So you could take a Pojo. On a Pojo, you would set up certain annotations. Let me show you a simple sample here. So, for example, here I have a resource. On a resource, I will say add path. I'll say this is a URI where my REST endpoint is published. Once you try to access this resource using HTTP GET, call this method. You want to say /fruit and a specific name and call this business method. So again, HTTP GET. The name is automatically being mapped to the method parameter here. You want to do post, put, delete, all of those URIs are mapped. That was what was done in JAX-RS 1.1 or the very first version of JAX-RS. Now in JAX-RS 2.0, there's a brand new client API that is being added. So you can invoke a REST endpoint in a very standard way as well. Earlier, you had to use either curl or use implementation specific APIs. Okay, so let's take a look at how the client API looks like. So once again, my resource here is path at persons. Then I have a get. In get, I'm saying, oh, this get list could generate a XML representation or a JSON representation. This is at a particular path, so /persons, give me the ID. In post, I'm saying I'm going to consume HTML form here. Okay, so let's take a look at my test package here. So my entry point here is client builder. Okay, so I'm going to say client builder, give me a new client. Once I get the new client, I specify the URI. That's my base URL for any REST endpoint. And I'm defining that as part of my application. So if I go here, for example, I say this is my base URI where all the resources are going to be starting from. So it becomes web resources /persons. Okay. Now all I'm doing here is I'm testing post and get together. I'm posting a few HTML forms, simulating them, and then getting the values back. So let's see this. I'm going to create a multi-valued hash map, string. So name Penny, age 1. And the way I'm going to do it is, once I've gotten the target from client, I'm going to use that target to build a request and post an HTML form. Same thing here. I'm going to clear the map now. Now I'm going to add another name, another age, build the request, post the form. Okay. So this is my posting of request. Now once I have done the post, I want to get it. So I'm going to say target.builderRequest and get it. And this time when I get it, I know the exact type on which I'm going to get it. So I get a person array back. So I get a person array back. And then you can start asserting, oh, the list is this, first element is this, second element is this, and third element is this. So very simple, clean API, leveraging syntax and semantics, very similar to what's on the server side, allowing you to actually invoke a REST endpoint. So that's new addition to the JAX-RS API. In addition, it also defines something called as interceptors or entity interceptors and filters. Filters are useful if you just want to look at the HTTP headers or headers that are going back and forth between the requests. Certain times you may want to just look at the headers and act upon those, but at certain times you may want to look at the body. So that's why there's a very clear split. Filters are for headers and entity interceptors are when you want to look at the body. Because think about it, if you are writing an entity interceptor, that means you're looking at the body, that means you are potentially triggering a business logic, talking to a database, etc., which may not happen for a filter. So you keep your filters and entity interceptors separate. Now, a typical or a classic case where you may mix them together is you look at the HTTP headers using filters, and you see this is a header which says the content payload is application gzipped. So then what you will do is you look at the header, on the fly you will insert a HTTP or entity interceptor to application unzip it or ungzip it, so that the endpoint receives the appropriate payload for you correctly. So those kind of decisions can be made dynamically, and then you can insert the filters and the interceptors on the fly. In addition, it also gives you async client and async server. So, for example, on the server side, you can get an asynchronous programming model. It's not very clean at this point of time. So again, there is a lot of scope for there to be improved. But effectively, you get a request on the server side, you dispatch to a concurrency utilities and say, let the job be done over there. And when the response comes back, I will coordinate the response back to the client. Similarly, on the client side, you say, oh, I'm just going to call the server asynchronously. You get a future object back. And then from the future, you either get the response back or you play around with it. Okay, that's the JAX-RS sample. And literally what I'm showing you is a very small subset. Now CDI was a big game changer as part of JavaEE 6. So you know how you can do dependency injection as part of the platform itself. But in JavaEE 6, you had to add beans.xml to enable CDI. And that was frankly a source of a lot of errors. Oh, my bean is not getting injected. Oh, did you have an empty beans.xml? No. There you go. So that simplified things. So what we did in JavaEE 7 is we made beans.xml optional, wherein you don't have to add beans.xml. What that means is in that case, any bean that has a CDI scope annotation will be automatically injected for you. So let's take a look. So here I do have a beans.xml, but a new attribute that is added over here is bean discovery mode. And that discovery mode can take three values. All, which means all the beans in the POJO or in the archive are available for injection. It can take the value annotated, which is the default value. What that means is any bean in the archive annotated to the CDI scope is available for injection. Or there's a single point where you can turn off injection completely by saying bean discovery mode is none. So those are the three values it can take. So if I go here, for example, here I'm explicitly specifying annotated as a bean discovery mode. If I don't have this file, that will work exactly the same behavior. That will exactly have the same behavior. There are a lot of other minor features that were added to CDI. I won't dig into the details, so I'll let you play with that. I'll show you something that I find very handy, specifically for the JPA applications. Now, up until JPA 2.0, you had the ability to take database and from the database generate JPA entities from it. What was missing is, hey, I'm a JPA model designer. I've designed my JPA entities. Now you generate SQL scripts for me from that. So that's the new functionality that is added in JPA now. So let me show you that. So here is my persistence.xml. In persistence.xml, I can say schema generation scripts action. So what I'm going to do is generate the scripts that are going to do drop and create for me the database. Okay. Then you're specifying scripts create target and scripts drop target. So if I run this test, for example, it's going to generate the scripts into /tmp/create.sql/tmp/drop.sql. So it looks at my JPA model and generate those scripts for me. So the way typically I see people using these is they start with a JPA entity because that's what they're comfortable with. They create their JPA model. Then from the JPA model, they generate the scripts. Then they fine-tune the scripts, and from that, they regenerate the JPA entities as well. It's not a full two-way loop where you can take a JPA, generate your scripts, tune them, and then reconfigure your entities, because you don't know how the scripts have been tuned, how the database tables have been normalized, denormalized. So it's a one way, but at least that one way in both directions is possible now, wherein you start with JPA, generate scripts, or take scripts and generate JPA entities. You can of course generate scripts, but you can also say just generate the database directly itself. So don't worry about scripts. Now JPA had this ability to specify named query, which is basically using Java persistence query language to query over a database. In addition, in this version of JPA, it allows you to do stored procedure as well. So hey, here's a database. The database has a stored procedure. I want a portable way to tap into that database and get a handle to the stored procedure. How many people use bean validation or know about bean validation? Some of you. Okay, cool. So now bean validation was again yet another very cool specification that was added to the JavaEE 6 platform. But in JavaEE 6, bean validation was really confined to effectively JSF and JPA. So what that means is you could have a JSF page with a backing bean. On the backing bean, you can specify your bean validation constraints, which is like at not null or at size or at min, etc. And then if you are entering the data in the JSF page, when you click on submit, those constraints are automatically honored. Similarly, on a JPA, you could say, oh, I'm going to persist this entity, but if the constraints defined on the entity are not met through a constraint violation exception. So it was basically restricted to those two levels. Now bean validation is a lot more widely applicable. So for example, you are having a REST endpoint which is consuming data from HTML form. You can start specifying validation constraints at that URL or at that resource very easily. Let me show you a sample. So here, for example, this is just a POJO. It's a CDI bean request scope. I'm saying show list, but when you are showing the list here, I'm passing a parameter. The list must be not null. I'm basically displaying the list in a particular way. All I'm saying is the list must be not null. It must be size minimum 1, maximum 3, and the prefix must be not null as well. And what that gives you is a declarative way of defining your constraints. So instead of saying if list equals null, return. If list.size less than 1, greater than 3, return whatever, or throw an exception. If prefix equals null, return that. So instead of having those bunch of if-else loops, you're just declaratively defining it and letting the container do the real magic for you, where it generates that appropriate constraint violation exception. All right, so it's top of the hour, a little over that. I'm going to show one more sample. Something else that we have added very cool in JavaEE 7 is how you can have transaction, like how you can have container managed transactions in a POJO. I mean, before JavaEE 7, you could do that only in an EJB. But now you can take a POJO. On a POJO, you can put an annotation called as add transactional. So if we look at that, wrong class. Yeah, so here what you have is a simple class. There is no annotation on it, Pojo. In here you have a method called as with transaction, another one without transaction. Okay. I want to make this method transactional, so I just put the constraint or the annotation called as add transactional. That's it. That makes the method transactional, and that's coming from the JavaX transaction package. In addition, we also define something called as transaction scoped. So I can define the scope of a bean to be within a transaction. Now this is a CDI scope, so what that means is when you try to inject the bean, all you get is a proxy. When you actually ask for a bean instance, at that point it figure out what the scope of the bean is and then provide you an instance or back it up with an instance. So here you're saying give me bean 1, my transaction scope bean, and at inject. Okay, so if I look at my transaction scope bean here, this is transaction scoped. Now if I try to access bean 1 and bean 2 within the method with transaction, it says it's going to give me ID 1 and ID 2. Now because the way CDI works, ID 1 and ID 2, their references within this method are going to be exactly alike. Okay, because it's in a transaction and the bean is supposed to be transaction scope bean. So the first time it tries to inject bean 1, it says, oh, you know what, there is a transaction scope, there is no transaction scope bean. Let me create an instance and put it into the pool and back it up with bean 1. But when you try to inject bean 2, it says, oh, the bean already exists in that scope. Let me just back it up to the bean 2 proxy. So ID 1 and ID 2 will be exactly alike. On the other hand, and without transaction, when you say bean1.getID, it will actually throw an exception called as context not active exception. And the reason it will do that is because the bean is defined to be within transaction and no user transaction or container transaction is running over here. Okay, so that's something typically people are very excited about because you no longer have to confine yourself to an EJB. On any Pojo, you can randomly put add transaction annotation and all methods become transactional, or you can put it on a specific method to make it transactional.
So you don't really need to use EGBs anymore if you're not going to do, for example, remote calls or something like that. You can just as easily go with Pojos and use.
So there are still a few things that are exclusively in EJB, and we're already looking at how we can extract that and make them more generically available. Remoting is one. Concurrency is another one. You can define a pool for your stateless EJBs. Passivation is another one. Add schedule is another one. So those are the features which are remote, which are exclusive to EJB. Yeah, but they're already in the pipeline of getting extracted from the EJB specification, just like CDI. So CDI becomes a lot more critical specification in that case.
So eventually EGB will be deprecated
I hope so.
and replaced with CDI.
I hope so. Well, I hope EJBs are deprecated because these EJB has served a good use case so far, but I think the concepts of EJB can be a lot more widely applicable. That's the key part. That's the key part we need to understand. And they have served a really fantastic job. They did a pretty crappy job to begin with, but in JavaEE 6 and 7, they've done a good job. And I think it's time to move on and apply that maturity to a wider set of technologies now. Any other questions?
So any do's and don'ts for this kind of approach when things get actually a bit more complicated and so it's really some ideas?
For what? Do's and don'ts of what?
Yeah, do you have some do's and don'ts
For?
on the software head to actually go this way? Any special cases where you should avoid this kind of approaches, still stick with ACP, for example?
You mean add transactional?
Yeah.
No, actually, this is definitely, people are using it all over the place. People are definitely using it. And as I said, there are certain use cases that are only served by EJBs. So if you do want, all of the EJB transactional semantics are available. So you can say inherit a transaction, start a new transaction, all of those semantics are available here. Transaction scoped bean works in EJB if you want to do it that way. So there's a lot of cohesion between the platform, but I guess the future direction is more towards CDI.
What about security?
Security is yet, there is a rumor that there is a new security JSR that is going to get filed as part of JavaEE 8, and that should address that as well. Doing security in JavaEE application is not easy right now. It's pretty ugly. So that's hopefully gonna get fixed, and then that is also one of the components that is targeted for being extracted out of EJB, again to be applied to a much more widely applicable POJOs. So and that's where my feeling comes in, from the part of the fact that EJB is gonna be like it was sort of a yesteryear technology. Now let's apply it to a more widely POJOs. Who knows, what's going to happen in 5 years, but that's at least the thought process today. I mean, when we created EJBs as part of J2EE 1.2, I thought we did a pretty good damn job, but then we realized we did a dang job. So it's a constant learning, right?
Yes.
It's constant learning.
I like the added flexibility that comes with, like extracting stuff from the EJBs and being able to use them all over the place, but it will probably put a lot of strain on the design in the future. Previously, we would kind of count on these things being done in EJBs. Now they can have it all over the place, so you have to pay attention.
Yeah. So it's more like, you take a POJO. Oh, I want transaction. Add transaction. I want security. So this is very much like Spring-like model, but a standard way, and which is going to be supported by all different app servers as well. And I think that's a constant cycle anyway. Spring is here because JavaEE didn't do a good job to begin with. Now JavaEE 7 did a really good job, and we're seeing a lot of migrations from Spring to JavaEE 7 all the time. As a matter of fact, I was in India earlier, all of last week, met lots of customers. They're using Spring primarily for their legacy applications. Their modern applications, they do want to start with JavaEE 6 and 7, because you're putting too many eggs in one basket by using Spring. I mean, Spring has changed from Interface 21 to Spring Source to VMware and now Pivotal. And the reason VMware kicked them out because Spring Source doesn't make money for them. So the future of Spring is literally in hands of 3 or 4 people. So like Jürgen Holler and maybe some more people. On the other hand, JavaEE is a much bigger standard. So you bring up a good point, actually. So what I like to do is, I like to do this. Why JavaEE 6 is better than Spring. And I wrote that blog. So this was one of my most controversial blogs. We were talking about it earlier. I've written 1,531 blogs so far in about past 9.5 years. And this was indeed one of my most controversial blogs, written over 2 years ago. So this is a pretty detailed blog. So you can see how big the bar is here. I can scroll for pages and pages and pages here. So there's about 20 pages of comments here and about 72 comments. Well, 20 pages of content and 72 comments last I checked on it. So it's a very controversial blog, but I think it's still well grounded. But things have changed. This is like a 2-year-old blog. JavaEE 7 has happened. Spring 4.1 is now in the process. So things have gone better on both the fronts.
I think that's a good place to stop at. As you mentioned, you've written 1,500 blog posts so far, which is approximately one blog post every second day. And looking at them, the quality is really big. Arun is one of the most productive guys that I know.
Thank you.
And earlier during lunch today, you asked about offline mode in Vaadin. And I gave you one reply, but this is the second reply. This is Vaadin offline mode. This is the hammock, so you can go really offline when you're not writing the blog post instead.
Thank you.
And
Thank you.
I think we all want to give a big hand to Arun for this.
Thank you. Thank you very much. If you have any questions, feel free to ping me on Twitter. How do you find me on Twitter? You can Google me or do whatever. So I'm twitter.com/Arun Gupta. Shoot me a mail. I'm happy to follow up with you. Any questions, or I need a sample for this, I tried this, that didn't work. Shoot me a mail, arun.gupta@gmail.com. So simple ID, simple Arun-Gupta on GitHub. Find me anywhere. All right, thank you.